I'm going to be introducing Stewart Lewis. Stewart is a chartered professional on AusIMM and a mining and civil engineer, RPEQ, with an MBA and serve as the CEO of IMC Mining. He brings over 30 years experience across coal, gold, base metal projects worldwide. Stewart's work focuses on bridging the gap between strategy and operational planning, turning life of mine strategies into executable site plans. Throughout his career, he has delivered as a mine manager and CEO of international mining operations and has prepared numerous reports for IPOs and company boards. Stewart, welcome.
Thank you very much. Okay, one of my concerns coming into this, I normally don't do these things. Normally my staff does them, but for various reasons I ended up doing this one. And I was concerned it mightn't fit the audience, but having heard the presentation so far, it seems a fairly important theme of doing your strategic plans and then getting them across to with the executives that it suits them, and then getting them actually executed on site. And then the trick I've had then is cutting the presentation down to a 30-minute time frame. A lot of the principles I'm going to be presenting, like using Bayesian risk. We do a lot of AI work with creating sandboxed AI. We do ML training for our systems, and we develop our own LP solutions. So I've sort of tried to condense this into a real focus, just getting onto the link between strategic plans and mine sites and how we might get that sorted. IMC, just very quickly, where a lot of people would know of us, we've been around for a long time. We're a fairly different mine consulting group now in that we have a very small team focus, and we focus more on managing studies. So rather than have to utilise the employees we've got in-house, we will go and get the best employees. So if for instance, we're doing the Arakoon feasibility at the moment, we'll go and get the geologist that knows about bauxite. If we're doing a nickel project in New Caledonia, for instance, we'll go and choose the team that's suitable for that. So we have a small core team of experts, but then almost just manage and facilitate big studies. And the biggest study I've done was about $42 billion US worth. So, and that was a huge team of about 30 people I was managing to do that. So it's hard to read this. So what we've found is our strategic guys, they work with MineMax, obviously. And MineMax is an awesome tool for building, coherent, constraint-on strategic plans. But what we've found is we will go and finish those plans 1 year, then go back for one of the majors, and they won't have followed the plan at all. It's like Groundhog Day, we call it. So we just go and start again. You say your cut-off grade in this copper mine is supposed to be blah, and they just do something totally different. It's good for us because we keep getting consulting work out of it, but it's a bit disappointing when it's almost 90% of the time the plans haven't been actioned on. And so one of my focuses is trying to ensure that we get sensible plans out there. And fortunately, with my experience having been a mine manager in WA gold mines, and also CEO in charge of mining projects, part of what IMC does is we actually operate mines as well. So we take it from a feasibility study, then have to go and prove it by operating the mine. And we've done that with a few mines in Indonesia and in Mongolia and in New Caledonia as well. And then I've also got the benefit of being a civil engineer. So I've been on civil projects like the Sydney Harbour Tunnel, and I was actually the site engineer on the little bus station that's down the road there for a year or two. So I understand why this gap exists between executives and the strategic team, and I'm sort of coming up with concepts of how we can solve that problem. What we've found is, and I think this was mentioned in other presentations, the siloing issue is the biggest issue. You'll go into a mine and you'll have the geologists don't talk to the mining engineers don't talk to the process team, and the process team don't talk to the marketing team. And the example I've got that up there is actually a real example of a mine that ended up shutting down. And it should have been a very selectively run mine, and the KPIs for the guys up on the hill was mining cost. So they went and saved themselves $10 a tonne in mining cost by going to bulk mining. That cost the process plant an extra $50 a tonne, but there wasn't even a financial model that showed them the difference. The mine had one financial model, the plant had another financial model, and the mine went broke. And you see the same thing, you guys being WA based mostly would see it in gold mines, where you've got a gold focus and they'll go and high grade the hell out of it for 4 or 5 months, and then they ruin it for the next 5 years by high grading it. So part of what we're doing is, in a project we're doing now, rather than go and do a theoretical study all the way through, we've started up mining on a small scale, which probably bigger. You always do a trial mine, and usually that's to get samples for the process plant and things. What we're doing is 12 months worth of mining in parallel to the feasibility study, where we're trialling different grade control strategies and different bench heights, and basically all the parameters that would go into a MineMax LP, we're trialling out. So basically a soft scale project that gets real parameters into the feasibility study. And our hope is that that will prevent the team operating the mine from making excuses to why they can't achieve what they're supposed to achieve. So that's sort of step one of how we're getting the gap between theory and practice. A big part of what we push, though, is zero-based financial modelling. What we've found, unfortunately, I get exposure to models from operating mines right through to the board of directors, and almost universally, they're different models. And so a big part of what we push is to have a zero-based financial operating cost model. It's just one model for everyone, and you might have different access levels to it for different parts of the organisation. But essentially, if we go and do a strategic plan and it says this is the NPV, the operating team have the same model. So that's a huge part of our focus. And our system is a cloud-based cost modelling system that there's different access levels for executives and things, see different parts of it. The biggest danger we've got is Excel spreadsheets. And we see this all the time. So for 30 years, I've been working on these things, and not once have I come across a corporate spreadsheet that hasn't got fundamental mistakes in it. There's just, it gets bastardized over time and people put their own little formulas in there. And my staff are just as guilty of it as anyone else. And that's why we've tried to move away from it, but to try and sort of track down problems. And some of them are huge. Like there was one of the biggest gold mines in the world that we were working on, and it made about a 2% difference to the NPV just in fixing up errors in the spreadsheet. The other issue, which was alluded to before, was, you can see that's just one of the MineMax things we've worked on with a logic flow on it. They tend to be complicated like that, and there's just so many levers to pull. You can disappear forever just pulling little tiny levers that make almost no difference to the outcome. And, you know, we've had one project last year, I think we ran 100 different scenarios, and it's a bit like the life of asset planning team come and say, I want to do blah, blah. You think, why do you want to do it? No one cares. So part of what we want to do is stop stop that churn. Again, it's a bit counterproductive for us because we get paid to do it, but I think we can add more value to clients by closing the loop and getting practical plans out, because at the moment almost no one's happy with the plans we get out, especially when you run 100 of them. So part of what we're doing now is we still run quite a few optimizations, but we try and put some logic into it. We don't go and say, oh, we'll move when we create the plant from year 3 to year 4 or whatever. We'll keep them to be outside of MineMax. So we have a bunch of base optimizations. We then have a financial model that we know is going to be used right through the process, from the feasibility through to operations, through we even do budgets now with our cost models. And then the main thing we have now is a Bayesian risk that goes through, and a lot of it's machine learning, so it's AI based, but if the beauty of Bayesian risk is it lets you, hang on, I'll go to my notes. Okay, so most of you would be used to running risk scenarios. Is like Monte Carlo simulations where you have bell-shaped curves and things. Bayesian risk, you can have, you use, it's called asymmetrical risk. So as an example, is that up there? As an example, you might, if you've got your grade, say it's nickel grade, you're targeting 2% nickel, you know there's a much lower chance of your nickel grade being lower. So you'll put an 18% chance of your nickel grade being X amount lower, only a 6% chance of it being higher. Then there's all sorts of correlations with that you can build in, the correlations of what happens if the nickel grade changes. You increase your plant throughput, or you've got to increase your strip ratio. So you can put correlating factors between each of those risks. So you have grade risk and you have that asymmetrical, and then it then can go and impact other correlated risks. And you run that through, we got code that does it basically. So you run that through your system and it'll come up with each of your scenarios. You might have only, instead of 100 optimization churn scenarios, you might only have 10 you're running. You run that through your risk algorithm and it will come up with the percentage chance you've got of achieving that outcome. And then that's your metrics for the probability that your NPV is going to be better. That then helps you focus on the key risk elements, which might be, you put in you got a plant expansion and you say the chance of achieving the plant in 3 years' time is probably only 20%. It's probably going to blow out to 5 years, and it's going to be, instead of $250 million, it's going to be $350 million, and there's a 20% chance of that happening. So you build those into it, and you have this whole matrix that runs thousands of these risk things and comes up with a solution that is risk balanced, which might be very different than the static risk that you otherwise would have come up with. An interesting one, it's not in my notes, but a project I did recently, it was a trade-off between a $250 million plant improvement and I think it was about $2 billion plant rebuild. And I actually went in, normally I've been doing it so long, I know what the answer will be. I went in thinking it'd be the $2 billion plant rebuild. And once we ran it through our system, it was absolutely no-brainer that you don't do that. It was better from a risk basis to do the lower investment and then look in 10 years' time when you do the expansion. So it can actually give you quite a different answer than what you thought. You'd think we should have been doing this for a long time, but we couldn't. And there's various reasons, but one is the compute. Anyone who has a consulting business or probably even mines knows how expensive it is to get a decent computer that can run these things fast. We were spending sort of 15 to 20 grand for an okay computer. But now we basically have everything in the cloud. We can go and get an AWS server with whatever we want on it fairly cheap, and you're only paying by the hour. So we can get huge compute power now that we didn't used to be able to do. The other one is the coding. So up till probably 2 years ago, you had to have a bunch of really good programmers on staff. And the problem is a lot of those don't know much about the technical side of things. Now we've got, again, I don't know how many of you are coders, but like we use PyCharm to do our Python coding. And then you have Windsurf that goes and works with writing your code for you. And then Anthropic and Chat and various Gemini as well to assist with writing the code. So we can now write code that goes and drives a risk analysis probably in 2 days that would have taken months to do in the past. And it can be written by someone with, you need to have a basic amount of computer skills and understand what you're writing. But at the end of the day, you can punch stuff out pretty fast that you just couldn't do. And like I said in that last note there, the shift is now, even with who we employ, we don't employ coders first. We employ engineers who are sensible engineers with practical skills, and then we'll teach them how to code after that, or they can learn from Anthropic or whatever to do decent coding. So that's one big change, or 2 big changes. And then why is it good? It sort of goes back to the thing I mentioned before with when we made the decision whether to expand the plant or not. The highest NPV was to go and spend a lot of money expanding the process plant. But when you do the risk balance, there was a 70% chance we would achieve a $1 billion NPV without expanding the plant. And there was a 20% chance we would exceed that expanding the plant because there were just so many risks around timing and such. So it sort of became a totally different answer once you build the probability and risk into the answer. And, I think that's a key part of when you run MineMax. Don't churn out lots of solutions. Go and look at the risk of achieving those solutions, because the site ultimately has to be able to do what you're asking them to do as technical people. And geological uncertainty is obviously a big one. Mines aren't like a process plant. They almost never achieve the grade that's in the model. And so you need to build that risk in somehow. And you either let geologists do it through conditional simulation or whatever, or as engineers, we can actually put some common sense parameters around that. And lots of geologists here. Guess I don't employ you. We used to employ a lot of geologists, so I don't employ them anymore. Okay. So one of the guys here actually used to work for Ambitobi, so I can probably mention this one. So we did the feasibility study for a mine in Madagascar called Ambitobi, and it's a very complicated nickel project that has a pipeline, and I think it's 300 or 400 kilometres from memory. But it also has a big acid plant down the bottom. When you process nickel, one of its biggest constraints is your acid production. So what we did for that is, because often the acid plant would be broken down or the pipeline wouldn't be working so well. And so what we did is we ran 500 or 600 MineMax scenarios for different constraints on the acid plant and on the pipeline. We then trained a machine learning algorithm with all those outcomes for each pit and face and everything. So it basically for different operating parameters that knew what the cutoff grade should be and what the stockpiling strategy should be. And then our rocket science plan was that they could use that on a daily or weekly basis to go and work out what the cutoff grade should be. In theory, it was great and it worked really well in Brisbane, and it worked well when we had cloud computers. But the problem is in Madagascar, your internet's shit, and I just couldn't use it because it wasn't reliable enough to get onto the AWS computers to run these things and to get high-end computers that can run these sort of algorithms. You don't want to have them in-house, they're too expensive. So that was us trying to have a good idea, and a decade ago we just couldn't execute it. Why is it now possible? Starlink's a big game changer for us. Almost all our jobs are offshore. Obviously, jobs up in WA, they have fast internet, but offshore ones, not necessarily so. So New Caledonia, their internet's crap. But if with Starlink, you've now got high-speed internet, so suddenly the world's open to any mine almost in the world, where you can get, 300 megabit internet access, and that's reliable, except when there's a lot of rain, and link that through a server in the cloud. I've already mentioned the AI coding, and then obviously the cloud computing. So those three things together are really a game changer for what we can do on mine sites and what we should be doing. So this is another case study on what we are currently doing. So this is the mine that's currently in development. And what we've done is I don't know if anyone here is aware, you don't have to use ChatGPT or Gemini. You can have a closed system that builds on their tools. So you can have an AI system that works on OpenAI or works with Anthropic, and you inform that with information from your mine. So for this mine, it's linked to their ships that's on the way, it's linked to their stockpiles, it's linked to where they're mining, what faces they've got available. It's linked to the financial model, so it knows the different outcomes for different decisions. And it's also linked to a bunch of LP runs through MineMax, and then some of them through our own systems as well. So in that system, you can basically go in and you have different levels of access. So if you're the planning engineer on site, you can go and ask a simple question: what should I be doing with my cut-off grade today? Am I going to have enough stocks down on the ROM to load the ship when it gets here? And it'll answer that question in an informed way. So that's what's happening now. And the executives have access to the same system, so they can see in real time what's happening with the mine and what the costs are up on the hill, what the costs are at the plant, etc. So it's a pretty cool new world. And I think this was alluded to earlier, the hurdle to getting these things happening is no longer technology. We clearly have it. The hurdle is your site silos, and I come across this all the time. A lot of the work I do is due diligence or audits, and none of those people, geology, mining, maintenance, plant, finance, talk to each other. And how do we make them talk to each other? I don't know. But that's why we've come up with this sort of AI interface, so at least they might be forced to talk to each other and make some sensible decisions, at least in context. And hopefully when we go back each year, they'll have followed the plans that we've given them. This is like a pre-conclusion. So what we've done is we've replaced what we called optimization churn, which is running hundreds of useless MineMax optimizations. It's not MineMax's fault, it's the user's fault, and turned that into 6 or 7 really targeted optimizations. We then go and do a risk outcome against each of those, and end up with a plan that we can give to both the executive team and the mining team that says, this isn't 100% certain you can achieve this, but we're 70% certain you can achieve this outcome. And then that gets improved over time as we get more and more data. The second last slide. So I just thought I'd add this in at the end. It's not really a snub at MineMax, but it could be taken as that. We, in all our LP stuff, we use pulp. The benefit of pulp is it's agnostic to the solver. So you can use a simple free solver, or you can go to Gurobi, or don't think you can go to Cplex, but you can basically choose the solver. So in our system, if we've got a really complicated thing, we've got a paid Gurobi license, and we'll use that to solve it. But you've got GLPK and other free ones that can solve it there. We run it on cloud-hosted computers that we create the computers ourselves, and you can create a little cheap one, or you can create a high-end one with 64 CPUs that you can tell Gurobi to go and use all 64 of those to solve a problem. So a problem that might take a normal solver, like a lot of our things take 8 hours to run in MineMax, that cuts it down hugely. In terms of MineMax, it's one thing, we're one of the bigger users of MineMax, I think, and one thing that surprises us is there's not more uptake of MineMax in the industry. It's such a powerful tool and is so useful. And part of my view is I think it's just too expensive. And when people are running these things, they might only be doing it once a year. Who's going to spend, I don't even know how much it is, I should know because I pay the bill, but it's about 70 grand a year, I think, something like that. Is it that much? How much? One seat. One seat? How much is it a year? Anyway, it's not cheap, and you've seen a lot of software these days that's gone to cloud-based solutions where you can go and, if MineMax was sitting in the cloud, you could then go and choose your tool. You could get a MineMax, if they decoupled MineMax from Cplex, had it sitting there, you go and choose, I want to use MineMax. I don't need it to run super fast, so I'll go and get a cheaper computer that MineMax could offer, that cheaper computer, which Gurobi does as well. You could use a low-end one. You could go and add on your free solver, and then it's really cheap. That might take 3 days to run your solution, and it mightn't be very reproducible. But for a lot of engineers, if you're only paying $2 grand to do that, I think that's a good solution. And then you can get close to your final runs. You go and choose a faster machine. You use Cplex or Gurobi to run it. You pay MineMax a bit more money to use that higher-end machine, and end up with hopefully more uptake in the industry, because it's a fantastic tool. And probably the scary thing for companies like MineMax now is it's pretty easy to replicate this stuff, like pseudo flow. It's easy to replicate that. It's very often, a lot of it's available in the public domain. LP schedulers, again, it's in the public domain. The beauty of MineMax is, for a company like ours, it's recognised by the industry. So if we present it to clients, they're comfortable with having it, which is a good place to be. So probably half our LP stuff's done with our own code, but everything that the client sees is generally in MineMax with its sort of standardised reporting and such. And that's it. Thank you.